Good morning, children. Today we will discuss the remaining problems from exercise 1.1. If you see the third question, what is given? Square of any positive integer will be in the form of 3p or 3p plus 1. Square of any positive integer will be in the form of 3q or 3q plus 1. Now let a divided by 3. Let a divided by 3. Then the possible remainders are 0, 1, 2. So a can be written as a is equal to 3q or 3q plus 1 or 3q plus 2. Am I right, children? Now we have to find the square. We are going to deal with the square of any positive integer. That is, if a is equal to 3q, then a square can be written as 3q whole square. 3q whole square can be written as 9q square. Further, I can write it as 3 times of 3q square, that is equal to 3k. So it is in the form of 3q. Next, if a is equal to 3q plus 1, then a square value will be equal to 3q plus 1 whole square. Now it is what? A plus b whole square. If I expand, it is written as 3q whole square a square plus 2ab, 2 into 3q into 1 plus 1 square. Simply, this is 9q square plus 6q plus 1. Am I right? Yes. Now in this 2, I can take 3 common. So a square is equal to, if I take 3 common, then I can write it as 3q square plus 2q plus 1. It is equal to 3k plus 1. So a square, we have got it as in the form of 3k plus 1. Now if a is equal to 3q plus 2, now you square it, then a square a square is equal to 3q plus 2 whole square. This further I can write it as a square is equal to 9q square plus 2 into 3q into 2 plus 2 square. This is equal to 9q square plus 12q plus 4. This I can write 4 can be written as 3 plus 1. This is written as 9q square plus 12q plus 3 plus 1. In this overall I can take 3 common. So 3q square plus 4q plus 1 plus 1. This is written as 3k plus 1. See, a square is equal to 3k plus 1. A square is equal to 3k plus 1. A is equal to 3k. So from this, what can we decide? Yes, square of any positive integer will be in the form of, therefore, square of any positive integer will be in the form of 3q or 3q plus 1. Right, children? Now we will discuss the next question. What is the next question? Use division algorithm so that the cube of now square is completed. Now let us have a question based on cube. Right, children? Now cube of any positive integer. Question number 4. Cube of any positive integer is in the form of of 9m or 9m plus 1 or 9m plus 8. Okay, so we have 9. When you cube it, no, it will become very large number if I divide it with 9. You take it as a is equal to let a be any positive integer and b is equal to 3. So a will be equal to either 3q or 3q plus 1 or 3q plus 2. Now cube it. Case 1, a is equal to 3q. Cube it. A cube is equal to 3q whole cube. It is equal to a is equal to 3q whole cube. This I can write it as 27q cube. Now I want it in the form of 9m or 9m plus 1 or 9m plus 8. This now further I can write it as 9 times of 3q cube. This is like 9m. Right? This is case 1. Case 2. Case 2. A is equal to 3q plus 1. Now a cube is equal to 3q plus 1 whole cube. That is equal to 3q whole cube plus 3 times of 3q whole square into 1 plus 3 into 3q into 1 square plus 1 cube. In further expansion, I can write it as 27q cube plus this is also 27q square, that is equal to plus 9q plus 1. In overall, what is common? 9 is common. If I take 9 common, this is written as 3q cube plus 3q square plus q plus 1. Further, I can write this one as a cube is equal to 9m plus 1 because I can take this value as m. A cube is equal to 9m plus 1. So second condition also satisfied. Now case 3. Case 3. A is equal to 3q plus 2. Right, children? Now you cube it. A cube is equal to 3q plus 2 whole cube. This is written as 3q whole cube plus 3 into 3q whole square into 2 plus 3 into 3q into 2 square plus 2q. Right, children? Now if I further expand, a cube is equal to 27q cube plus 27 into 2, that is 54 q square plus 3 3s are 9, 9 4s are 36, 36q plus 8, 2 cube is 8. In overall, in all this 9 table is common. This if I take 9 table common, this is written as 3q cube plus 9 6 that is 6q square plus 4q plus 8. This is written as 9m plus 8. 9m plus 8. This is the third condition. So what can we say? Any positive integer can be written in the form of, cube of any positive integer. Cube of any positive integer is in the form of 9m or 9m plus 1 or 9m plus 8. Right, children? Now we will discuss the last problem from this session, from exercise 1.1. The last problem, what is that? The last problem is very beautiful problem and very, very important in this number system actually. What is that question? Fifth question, question number 5. What is given? Show that n plus 2 or n plus 4 is divisible by any one. So one and only one and only one out of n plus 2 or n plus 4 is divisible by by 3. Let n is divisible by 3. Then n is an integer will be in the form of 3q or 3q plus 1 or 3q plus 2, because remainders, possible remainders will be 1 0 1 2, 3q plus 2. Now case 1. In case 1, if n is equal to 3q, then n plus 2 will be equal to 3q plus 2. n plus 4 will be equal to 3q plus 4. That means it is 3q plus 3 plus 1. This I can write it as 3k plus 1. Now what is divisible? Here n is equal to 3q where remainder is 0. In the remaining two cases we have remainder. So therefore for n is equal to 3q is divisible by 3. N is equal to 3q is divisible by 3, and other two are not divisible. Other two are n plus 2 and better to write n plus 2 and n plus 4 are not divisible. Not divisible by 3. Next, case 2. Case 2. If n is equal to 3q plus 1, if n is equal to 3q plus 1, now n plus 2 value will become 3q plus 1 plus 2, that is 3q plus 3. 3 is taken common, q plus 1, that is equal to 3k. So n plus 2 is divisible by 3, and n plus 4 if we take, that is written as 3q plus 1 plus 4, that is equal to 3q plus 5. This is further we can write it as 3q plus 3 plus 2. In this 3 is common. If we take 3 common, then it will become 3k plus 2. 3k plus 2. So what is divisible here in this case? Only one out of n plus 2 and n plus 4. Only one is divisible by 3. Next, case 3. If we see case 3, if n is equal to 3q plus 2, if n is equal to 3q plus 2, what will happen? So 3q plus 2, remainder is 2, confirmed. Now n plus 2, if you take 3q plus 2 plus 2, this is written as 3q plus 4. Now 3q plus 4 further can be written as 3q plus 3 plus 1, that is 3k plus 1, because in this 3 is common. 3k plus 1. So n plus 2 is also not divisible. Now let us try with n plus 4. N plus 4, that is equal to 3q plus 2 plus 4, that is 3q plus 6. Now in this, if 3 variable is taken common, it is written as q plus 2, that is equal to 3k. See, now in this n plus 4 is divisible. In this case n plus 2 is divisible. In this case n is equal to 3q is divisible. So what can we say? One and only one. One and only one out of n plus 2 or n plus 4 is divisible by divisible by 3. Right, children, in the next session we will go with fundamental theorem of arithmetics. Have a nice day, take care, stay safe, stay home. God bless you all.